When node-based finite state machines start to feel like there's too much overhead because of having a different node for every state, you may be asking if there's another option. Well, good news, there is. In another video, we built a finite state machine using nodes in the scene tree. Today, we're taking a different approach, a script-based finite state machine that's lighter weight, faster to set up, and perfect when you don't need the visual organization of the scene tree. This method is great for enemy or NPC AI, UI state management, or anytime you want maximum performance with minimal overhead. Welcome back to JDDoesDev. I'm JD. Let's do some dev. The node-based approach to finite state machines is great for complex characters with lots of visual components, but sometimes you want something simpler and faster. Script-based finite state machines have several advantages. They're more performant because there's no scene tree overhead. Also, they're not tied to the scene system. Script-based finite state machines are just pure data, which make them perfect for save systems, enemy or NPC AI that remembers what it was doing between sessions, or even multiplayer. They work great for any non-visual systems and much simpler to debug since everything lives in one script. Usually the trade-off is less visual organization, but for most use cases, that's perfectly fine. Let's go ahead and dive into the code. First, we're going to get rid of all of these states here. And now we're going to start by creating a lot of things that are going to look a lot like the node-based, but with some significant differences. So first off, let's create the script state interface. Now this is going to be the base for all of our states. Instead of extending node, we're going to extend ref counted. And we're going to name our class state interface. Now a lot of these things are going to look identical to a node-based state machine. Going to have all the same virtual methods with some slight changes. The first change you might notice is that previous state is an enter. And the reason for this is that we're keeping track of what state we're coming from and what state we're going to. So we need to have this in the enter method. And this helps with conditional logic based on where we came from. For example, you might want to act differently if you're going to the idle state from jump as you would from walk. Everything else is pretty much the same. Let's build the script-based state machine itself. And we'll call it state machine. Open that up, and in this one, we're also extending ref counted. We're going to do class name state machine. We're going to keep the same variables, and since we're doing everything in code and not through the scene tree, we need a function to allow us to do that. So we're going to add in the add state. Now what this does is allows us to take the state, and instead of looking over the scene tree for child nodes of the state machine node, we are adding the states to a dictionary up here, the states dictionary. And then we set the state machine variable to self, which is this state machine. So now that we have a state machine class defined, we can go back to our state interface and create our state machine variable. Now, one other thing that we need to add in here is an owner. Because we are making a state machine that might be used in multiple places, or that you might use a pattern for, or there may be multiple state machines being used. We want to know which node or scene owns the state machine that's being used. So let's create that owner. Just var owner is plenty for that. We need to set the initial state. And we do that like this. We just run change state. Now, what do we do for change state? Well, there's quite a bit. Let's create the function change state. Now we're going to get the previous state name, which is going to be the current state name. So that's the existing state name of where we're coming from. If we have a current state, then we're going to exit. Remember, current state is already in our state machine object here. The next thing we're going to do is set the current state name to the new state name, and then we're going to get the current state from the states dictionary. The next, what we want to do is check if there's a current state, then we can enter into the current state. Now this may look confusing. Current state, enter previous state name. Now remember, back in our state interface, we have the enter function here having the previous state as an argument. So don't let that confuse you. Now, if it doesn't exist, then we're going to push a warning saying that a state isn't found. Now we need to do our update. Just like the other one, we're updating on every frame to take over process from the Godot virtual methods. Then we want to do our physics update. Then we want to handle input. And in case we want to know what our current state name is for debugging purposes, let's just add in get current state name here. Let's go ahead and create our character states. We're going to use the same three, idle, walk, and jump, that we used in the other video. So let's start with that. Create new script. Now, instead, we're going to be extending state interface, and we'll give it the idle state class name. So first thing that we want to do, just for debugging purposes, is have an enter function with our previous state, and we're going to print entering idle state. Now we want our handle input, so let's put that in, and we're going to do very similar to what we did in the node-based. Now the only inputs we're working with here are left, right, or jump, and we change state to walk or we change state to jump. Now let's go ahead and make our walk state. Extend state interface, class name. Now walk state, we need to know what the character is because we're going to be doing things to the character, having them move around, right? So we'll just make a character variable here. And then first thing that we need to do is enter. Then we know what the previous state is. Character is the state machine owner. We're setting that in the state machine. Now remember, the state machine is in the state interface here. So it's available since we're extending the state interface. The state machine variable exists. That's all we need to do for enter there. Now for physics update, that's where we're going to move around. So we start our physics update with our direction. Then if there's no direction, we go back to idle and we just jump out of the function. However, if there is a direction, we set the character velocity and move and slide. Finally, we're going to handle input because if somebody jumps while we're in the walk state, we want to know and we want to move to the right state. So if input is action, just press jump, state machine change state jump. Finally, let's do our jump state. Extend state interface. Since we're moving the character, we also need a reference to the character. So character body 2D, there we go. Now for enter, we're going to set the state machine owner is the character that we're doing movement on. And we set velocity Y as -400. So in this one, we're using the physics update. So we're going to apply gravity. So the character starts moving down. We're also going to allow for air movement. So we can go left or right. And then we do our move and slide on the character. If the character's on the floor, if the direction is here with the movement, then we're going to go to walk. But if direction is 0, then we're going to go to idle. So notice how we get the character reference through the state machine owner right here. We'll set this up in our character script. The states work exactly the same as before, but now they're lightweight classes instead of scene nodes. So let's go ahead and put it together with this character controller. We're going to go to our character body 2D, create a script. But first, we need a reference to our state machine. Now we're going to use the same virtual methods that we usually use in Godot, starting with ready. Then we're going to create the state machine. We do that by state machine new, and then setting the state machine owner to this character. Now we're going to add states here in the ready function. Before we did that by just adding nodes to the scene tree, but here we're going to create and add states this way. State machine add state idle, walk, and jump. And then we just take each one of those and create a new object there. And then we're going to start off in the idle state. Now we need to do everything that we did before, where our process function, we say that we're going to go to the state machine update function. Our physics process function is going to go to the physics update function. Our input is going to go to the handle input. And for debugging, in case we need it, let's just add this get current state. All right, and that's it. That's what we do for a code-based state machine. Now notice it's much cleaner than our node-based. Everything's set up in code. We create the state machine, add our states manually, and delegate Godot's built-in methods to the state machine. The owner property lets states access the character easily. So when should you use each approach? So use node-based. Use node-based when you want visual organization. You have complex states with multiple components, or you're building character controllers with lots of visual feedback. Now use script-based for AI systems, UI state management, simple character controllers, anywhere performance is critical. It's also better for procedural systems where you might create states dynamically at runtime. Now let's test it out. And let's test it out. We're in the idle state. Jump. Now, a challenge for you is I want you to go and try to use this in something that's not a character controller. And let me know what you come up with down in the comments. And we've been over 2 different approaches to finite state machines in Godot 4. The script-based approach that we covered here gives you maximum performance and flexibility. And the node-based approach that we did in another video gives better organization for complex systems, but both solve the same spaghetti code problems that we're trying to solve. Try both approaches and see which fits your project better. Thanks for watching. Let me know in the comments what you would like to see the next video cover. If you like this video, please don't forget to like, subscribe, and comment to the channel. It means a ton. And if you'd like to watch more in live game dev, feel free to check me out on Twitch at twitch.tv/JDDoesDev. And big thanks to my Ko-fi supporters. Without all of you, this wouldn't be possible, so I appreciate you. If you'd like to help out and support me on Ko-fi, there's a link down in the description. Every bit helps, and I'll see you on the next one. I'm JD. This has been JDDoesDev. Thanks for watching.